Hello, my name's Jonathan Hedgecock from Ricardo Energy and Environment in the UK, and it's my pleasure to be with you and to speak about enabling regulatory frameworks for clean energy and some of the best practices that we see internationally in this area. In the course of the next few minutes, I want to introduce Ricardo Energy and Environment to you briefly, and then I want to talk about three specific areas in which regulation can assist the development of clean energy projects. First of all, looking at generation connection guidance and how this can be best provided to new entrants into the renewable generation market. Then something about the way in which regulation can support energy storage and the important role that storage can play in facilitating renewables on our networks. And then finally, something about regulatory frameworks and the way that harmonizing regulations across regions, including island systems, can enable the creation of a level playing field, which enables new investments in renewable energy to come forward. First, a bit about Ricardo. We are based in the UK and in the energy and environment part of the business, which numbers a team of some 450 people. We are responding to major global market drivers in energy that we see in the current time. This includes decarbonisation of transport and energy, the rapid urbanisation that we see going on internationally, and the importance of giving equal access to communities, whether they are grid connected or off-grid, equal access to energy that is supplied in a reliable and sustainable way. In the electricity infrastructure and networks team that I'm part of, we're very much focused on power planning, on techno-economic evaluation of power projects, and on regulation. And we have worked internationally in the Caribbean, in the South Pacific, in Southeast Asia, in Sub-Saharan Africa, and in Latin America, as well as in the UK, on regulatory issues facing network owners, operators, and the power industry as a whole, as we come to terms with the need to encourage new investment in renewable generation. Turning to the first of our specific topics on regulation in supporting the connection of clean energy sources to the networks. Providing generation connection guidance is important, particularly when we think about how significant it is to maintain power system security and power quality as the penetration of renewables on our systems increases. Renewable generators bring a number of technical challenges to the networks. We have the reduction in inertia, which can result from increased renewable penetration, and the intermittency of the renewable generation output itself. We also have the fact that renewable generators are distributed across the network, and so this can result in reversal of power flows on parts of the distribution system, which create challenges for system operators in having visibility of what is happening and maintaining control of the generation as system operating regimes change. In addition, the proliferation of renewable generation results in many more stakeholder interfaces between network operators and the owners and operators of the renewable plants themselves. Add to this the fact that the demand side can become involved in more exciting and challenging ways through demand response, customer flexibility with their loads, the increased connection of electric vehicles and possible vehicle-to-grid implications, and we can see that there's a whole range of new stakeholder interfaces emerging which need information provision from network operators and clear regulation to ensure that they are managed properly. If we look at how to provide information to renewable generators about the technical requirements that they must meet in order to help network operators maintain supply quality and reliability, then it's important to highlight the enhanced technical requirements that are required to give whole system support from renewables as they enter the system. So it's important to classify generators by type of generation and the technologies behind them. It's important to set down reactive power requirements so that voltage control can be maintained. Also, fault ride-through capability to ensure that renewable generators will stay on the system and help system recovery after faults have taken place. Getting enhanced system support from inverters through things like synthetic inertia that enable greater control of the power system can be important, and ensuring that there's adequate frequency response. That can include frequency response from generators and potentially from storage requirements, all part of ensuring that we have technical requirements clearly defined in regulations. And the best way of doing that is through the distribution code. We've been working with organisations in the UK to develop new industry standards which are related to the distribution code, and we've noted them there, G98 and G99, which provide details of the particular connection requirements that renewable generators need to maintain and to support the operation of the grid system when they become connected. When it comes to the interface between network operators and the generators themselves, it's very important to have clearly defined rules and processes for how generators become connected and how they operate once they are connected. This again is an important role for regulation. So the way in which connection applications must be submitted, how generators understand the reinforcement costs to which they could be exposed. What about active network management options and the possible way in which greater access to limited connection capacity can be given by managing the generators themselves and asking them to disconnect at certain times in the operation of the system. One of the big issues concerning the application for new connections is what you do about applications that are competing for the same capacity. And so how is a queue formed, and how do we decide on the priorities between different applications? The connection agreement itself is an important document, and generators often need help in understanding how to navigate the negotiation of those agreements. And there are other issues to do with compliance with system operating practices, the monitoring and the availability of metering systems, control systems, all sorts of other technical aspects which generators are not necessarily familiar with before they seek an application to connect to the system. We have been involved in the UK in the development of distributed generation connection guides to assist the developers of renewable generation in particular in knowing what the requirements are that they'll need to comply with when they come forward for connection. Turning to the sort of regulation that is needed to support the integration of energy storage into systems, this is a relatively new and emerging area, and we find that generally regulation can tend not to be very well aligned to facilitating storage solutions. Storage operators may find that they are faced with charges coming from different sources. They may have to pay demand use of system charges as well as generation charges because of the two modes in which storage can work. They may find themselves exposed to balancing charges resulting from the fact that they are generating at one moment and absorbing power at another. If they are locating at the same site as generation, then it may be that suddenly two generation licenses are required, one for the generator itself and one for the storage solution. Is this right, and is this the sort of policy that we want to have in place? There can also be a lack of transparency as to where the networks themselves can solve problems as well as generation, and so trying to get an integrated solution involving storage, generation and networks can be very important, and having well-defined processes for doing that will assist all parties in reaching a good solution. If we look at the way in which storage can be applied, then clearly there are opportunities here for generators to benefit from the application of storage, which means that at times of excess generation output, that can be stored in a location close to the generating site, particularly if, for example, there is not sufficient grid capacity to export from the site at particular times. This can result in reduced connection costs because less connection capacity is required, and therefore a faster connection time if the development of the generation can be integrated with the development of storage. There can also be increased revenue opportunities arising for generation which would otherwise have been constrained. Storage operators themselves will receive remuneration for the services they provide either to the generator or to the network operator, particularly if they're providing ancillary services, that's to say support at particular times on the network when either reactive power or the support from frequency response is required. And the network operators themselves can benefit from these increased availability of ancillary services, giving them greater operational flexibility. Finally, something about regulatory frameworks and the way that these can support regional energy market developments. One of the objectives of looking at regulation on a regional basis is to try to create a sustainable regional market which attracts new investment and also promotes sustainable development. Trying to do this at a regional level means creating a framework for regulatory oversight that tries to harmonise regulations between national and regional regulatory bodies, and therefore creates a level playing field for new investors entering either island systems or continental systems. It's important to achieve an appropriate balance between the national and regional regulatory bodies when we do this, and also to look at the capacity building requirements that might be necessary to ensure that regulators are aware of the sort of best practices we've been talking about already, and enabling them to play their part to the full in developing harmonised regional regulatory systems. We've recently been doing some work on the development of a framework for regulatory oversight in the regional energy market of Eastern Africa, Southern Africa, and the Indian Ocean. So this includes continental systems and island systems. And there were a number of key objectives in this work. We looked at the roles of the regional energy regulatory bodies that exist and the associations of national regulators and how they can help to establish appropriate regulatory instruments, market monitoring and surveillance programs for the regional energy market as a whole. We looked at the way that transmission and distribution pricing methodologies can promote investments in regional infrastructure and also enable new generation developments to come forward on a clearly defined basis. This includes looking at the open access requirements that give the rights of all parties to access transmission and distribution networks for the trading of energy. And we also looked at designing a responsive training program responsive to the needs of the regulatory institutions and making sure that they have the skills available to set them up for the regulation in a complex and fast-moving area going forward. The way in which we did this was to look first of all at the roles of the wide range of regional regulatory bodies that exist in sub-Saharan Africa, in Eastern Africa and the Indian Ocean. And some of those bodies are shown on this slide here. And beginning by looking at regional legislation and regulations defined at the highest level with economic cooperation bodies as well as regulatory institutions. And then looking at what happens nationally in terms of network pricing regimes, the legislation and regulations that are in place in each country, and the codes and operating standards that support the operation of the power sector in each country. By seeking to bring all of these together and identifying the appropriate boundaries between regional and national regulatory arrangements, then we were able to make recommendations on areas where regulations should be harmonised. We identified 3 priority areas for the harmonisation of regulations, looking first of all at licensing and the sorts of guidelines that are in place for different types of licenses that may be required, and also the standard licence conditions which would help to enable new entrants into the energy market to understand the obligations upon them. We also looked at network regulations specifically, and particularly transmission connection use of system agreements, network tariffs, and the requirements for regional grid codes. And finally, we looked at market regulations and the areas affecting market access, whether it's appropriate to have templates for power purchase agreements and the sorts of market surveillance and dispute resolution procedures that are required. So in summary, I think we've seen from this brief overview that international best practice in regulation really can facilitate the transition to clean and sustainable energy. Specific areas where it's important are in generation connection guidance to enable network access for renewables, regulation to facilitate storage solutions to be part of the networks, and the regulatory frameworks that can be developed across regions, across multiple islands and continents to lead to increased investment in the power sector and encourage sustainable development. Thank you very much for your time.